These superelements are driving innovation, everything from smartphones to MRI scanners.
That's the magic stuff.
But there's a problem. They're rare, and they're already running out. The stuff that makes smartphones work could be gone in a decade.
There are phones, our cameras, our sat-navs, our notebooks, our diaries. You can watch a film on them, you can book a flight on them, you can check your bank balance on them. You can even film a whole BBC documentary on them. But for a material scientist like me, it's what's inside these smartphones that's so impressive.
To prove just how good superelements have made our phones, we're going to film this program on them. Now, there we go. Microphone. Look at all these little processors doing all the processing of your speech. There's loads of different metals inside. Silver, copper, and platinum to start with. But that's not all. That's what I'm after there. That's gold. There's 300 times more gold in a kilo of smartphones than a kilo of gold ore. Your average smartphone contains over half the elements on the planet. There's lithium and cobalt in the battery, lanthanum and yttrium in the screen, terbium and dysprosium make the microphone. There's even arsenic in the silicon chip. Each element has a unique role to play, making our phones slimmer, smarter, and more powerful. But one stands out from the rest. A rare metal with a magical property. The phones got smaller and smarter, and some of them could even connect to the internet. But they still needed a keyboard, and that limited their powers. Then some clever scientists discovered the superpowers of an element called indium. And here it is, indium. Now, one of the tricks for understanding this metal is to have a bite, because it's so soft you can chew it. I mean, not a good substitute for chewing gum, but nevertheless, an amazing thing, but not as amazing as what I'm about to show you. If I take indium and I do this, watch what happens. Amazingly, it can turn into a liquid. But that's just the start of indium's weird and wonderful properties. Now, if I take this liquid, I ought to be able to paint a line on this piece of paper. I've got a light bulb here, and there's two wires connecting it to this power source. And when there's a circuit, then the light comes on. And the question is, will this liquid metal I've just created conduct electricity? And the answer is yes! Brilliant. So we have a soft metal that can turn into a liquid that conducts electricity. Not bad. But it has one more astonishing property. The thing that makes it an absolutely vital part of every smartphone. Mix it with tin and oxygen and you get indium tin oxide, a transparent electrical conductor. And that's how you make the touchscreen. They appear so simple, even a toddler can master them. In nature, indium is found tightly bound to other metals, most commonly zinc. To coax it out of zinc ore, you have to dissolve the rock in acid, then bake the acid in a furnace, then mix a precise cocktail of other chemicals to finally extract a minuscule amount of pure indium. But if you do the maths, you find a problem. There's only a tiny sprinkling of indium in every smartphone, approximately 0.02 grams. But we buy 1 billion smartphones a year. That's a big number.
If we add in all the other uses of indium, like tablets, other flat screen devices, and all the other electronics that use indium, we get a number of 700 tons of indium that we need every year. But in 2008, the US Geological Survey estimated that there was 16,000 tons available. Now, if that was right, at the rate of 700 tons per year, we would be running out of indium in the next decade.
Then again, maybe not, because as it gets scarce, the price goes up, and that encourages companies to go out looking for more. The problem is that takes time, and it's a bottleneck that could be the stuff of nightmares. Imagine young people of the future, unable to have phones. Unthinkable! Relatively recent addition to the periodic table. Neodymium. Lithium. None more so than helium. It's made from tungsten carbide.